Alright, section 15.1, evaluating radicals. Alright, before we get too deep into this, we need to go and go through some terminology. Let me go ahead and get the pen ready here. Okay, what is a radical? You've seen them before, okay? Sometimes they freak people out, okay? But let's kind of, like I said, go through the terminology here. The symbol right there is called the radical sign. The number under the radical sign is called the radicand. And the complete expression, such as the square root of 64, is called the radical or radical expression. Okay, what is a radical though? Okay, let's look at this. Okay, you're going to end up having a square. Okay, so you have a square here, and it's a perfect square. Okay, which means it's going to have a side here of x and a side here of x, which means they're equal. Now, my square is obviously not equal, but if we continue along and thinking they are, if we multiply both of these together, we've got x times x, which equals x squared. Well, that's all fair and good, but if you have a bedroom and I say, hey, what is the area of your bedroom? That's great. You can give that to me by going, okay, well, it's x times x. I multiply both sides together. Here's the area. But what if I said to you, and I know that your room is a perfect square, what is the length of one side? Well, this is where the square roots come in. And by doing that, I can take the square root of this number, and it will get me back to the original x value. Get me back to the original length right there. Okay, this will become more apparent as time goes on. Just kind of, we'll do plenty of examples. So let's go through here, looking through more examples. If a is a non-negative real number, then the square root of a is the principal square root a, and then negative, the square root of a, is the negative square root of a. Okay, notice here, this is like saying that you have the negative square root of 4, okay, equals negative 2. Basically, you're taking the root here and then making it, this negative is just kind of going along with it, okay? Note, square roots of negative numbers are not real numbers. For example, the square root of negative 4 is not a real number. There is no real number whose square is negative 4. This is saying, can you have a bedroom with sides of negative x and negative x? It's saying, can you have negative length? No. Okay? So when you multiply those together, notice if you did have a negative, if you multiply negative times a negative, you're going to end up having a positive anyway. This is what that is. This is what that is basically saying. Okay, so let's kind of continue on. Okay, rational numbers. A rational number is a number that can be in the form of p divided by q. Okay, I'll write that out kind of more normal. That's what that would look like. Where p and q are integers, remember, counting numbers, and q is not equal to 0 because we know by now that you cannot divide by 0, because if you do, it is undefined. Okay. In rational numbers, we're going to have things called terminating decimal and a repeating decimal. A terminating decimal is something like it goes 0.2. Notice it doesn't go any further than that. Or you could have 0, for repeating, you could have 0.222, and then they put a little line on top. That will be a repeating decimal. Those are counted as rational numbers. But so is 1/2. Okay, or something that looks like 0.125, because notice that 125, it's going to repeat forever. Okay, we can kind of even show it like that. That's basically the little dot, dot, dot. That means forever. Just going to kind of keep going on and on and on. Okay. Also notice, how do I put this? I want to say this the right way. Rational numbers are fractions, okay? So every fraction can become a decimal, but not every decimal can become a fraction. For example, an irrational number is a real number that cannot be made by dividing two integers, okay? It has no fractional part, such as pi, which is, 3.1415 dot, 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 never, let's do this, never repeats, is not, there's no sort of, it's completely random. You've got the number e, which if you're taking finance classes, you'll see that. The square root of 2 is irrational. 0.21879 ... Notice there's no rhyme or reason. That makes it irrational. Okay. Continuing on, if a is a real number, then the cube root of a is the cube root of a. There you go. Attention, the cube root expression of the number 3 is called the index. In a square root expression such as this one here, the index is understood to be 2. So when this part right here is blank, it's always going to be a square root. Okay, we don't write it. Expressions with square roots and cube roots as well as other roots are called radical expressions. Okay, last little example here of what is a cube root. Well, we learned that the area of a room, okay, can be defined as x times x. Well, let's move that x actually. Let me move that. It's going to get in the way here. Of x times x. Well, a cube root is literally just as it sounds. It's going to take the area of a cube. So, when I say area, I mean volume. Let's be very specific with our wording here. So you've got a length, okay, a length, a width, and a height. Okay, so it would kind of look like that, where you have x times x times x equals x to the power 3, or x cubed. Okay, well, to get rid of that, okay, so I now ask you, hey, what is the cubic feet of your room? And you have a perfect cube room, and you can go, oh, well, it's this. Okay, that's great, but what is the length of one side? You know, be it height, width, length. What is the length of that? And you can go, oh, okay, well, hold on, and I will give you the cube root of that, and that takes me back down to x. One thing that should be maybe apparent by now, that if you have something to a power, its inverse is the root version of that. Notice this cube root, okay, gets rid of a power of 3. A fourth root would get rid of a power of 4. A square root gets rid of something like x squared, okay, and so on and so forth. So roots are the powers of the inverse of roots, and roots are the inverse of powers, which we'll see more of that later. So just kind of wanted to throw that out there. So let's go ahead and get into some Hawks examples.